Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from Group 2. In this video, we will study Newton's law of motion. This material is part of physics learning for grade 11 students. Through this lesson, we will understand how force affects the motion of objects in our daily life. The learning object of this lesson is students will learn about the Newton's laws of motion. Introduction to Newton's laws. In this slide, we discuss the brief history of Newton's laws. These laws were formulated by Isaac Newton in the 17th century and published in his book Philosophiae Naturalis Principia Mathematica. Newton's laws explain the relationship between force and motion. There are three Newton's laws. The first law explains inertia, meaning an object will remain or at rest or move at constant velocity unless acted upon by a force. The second law explains the relationship between force, mass, and acceleration, expressed as F equals m multiplied by A. The third law explains action and reaction, where every action has an equal and opposite reaction. The learning objective of this material is to help students understand the meaning and usefulness of Newton's laws. Newton's first law. In this slide, we discuss Newton's first law, also known as the law of inertia. This law states that an object at rest will remain at rest, and an object in motion will continue moving at constant speed and in a straight line unless acted upon by an unbalanced force. The formula shown here is sigma F equals 0. This means the net force acting on the object is 0, so there is no change in its motion. The learning objective is for students to be able to understand and explain Newton's first law. Now, let us look at example of Newton's first law in daily life. The first example is a stationary ball. The ball will remain at rest until a force, such as kick, is applied to it. The second example is passenger in a car. When the car stops suddenly, the passenger move forward because their body tends to continue in motion due to inertia. The learning of objective is for students to be able to identify example of Newton's first law in everyday life. Next, we move to Newton's second law. The statement of Newton's second law is the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. This means that the greater the net force applied to an object, the greater its acceleration. However, the greater the mass of the object, the smaller its acceleration. The mathematical formula of Newton's second law is F equals m multiplied by A, where F is represent force and is measured in newtons. M represent mass and is measured in kilograms. A represent acceleration and is measured in meter per second squared. If the force increases, acceleration increases. If the mass increases, acceleration decreases. Okay guys, so the learning objectives of this slide is students are able to explain the relationship between force, mass, and acceleration. Now, let us examine example of Newton's second law. When a person pushes a shopping cart with greater force, the cart accelerates more quickly. However, if the cart is heavier, its acceleration becomes smaller even if the same force is applied. Another example is kicking a ball. The stronger the kick, the greater the force and the faster the ball accelerates. Okay, the learning objective is for students to be able to apply Newton's second law in simple situation. Now, we will discuss Newton's third law. The statement of Newton's third law is whenever one object exerts a force on a second object, the second object exerts a force of equal magnitude and in the opposite direction on the first object. This means that every action has an equal and opposite reactions. Action and reaction force always occur in pairs and act on different objects. And the learning objectives, students will be able to explain the concept of action and reaction. Okay, let us look at example of Newton's third law. When a hammer hits a nail, the nail also exerts an equal force back on the hammer. Another example is a rocket launch. The rocket pushes gas downward. The gas then pushes the rocket upward with an equal force in the opposite direction. Another example is a rowing a boat. The paddle pushes the water backward, and the water pushes the boat forward. The learning objectives of this slide is students will be able to identify pairs of action-reaction force. Now, we will solve a sample problem using Newton's second law. And the question is, an object with a mass of 5 kilograms is pushed with a force of 25 Newton on a smooth surface. Determine the acceleration of the object. Okay, so we use the formula F equals m multiplied by a. To find acceleration, we rearrange the formula into a equals F divided by m. Then we substitute the values. Acceleration equals 25 newtons divided by 5 kilograms. The result is 5 meters per second squared. Therefore, the acceleration of the object is 5 meters per second squared. Okay, so the learning objective on this slide is students are able to calculate the acceleration of object using Newton's second law. Okay, in conclusion, Newton's first law discusses the inertia of object. Newton's second law explains the relationship between force, mass, and acceleration. Meanwhile, Newton's third law discusses action and reaction. By understanding these three Newton laws, we can explain various motion events that occur in everyday life. Okay, so thank you guys for watching this educational video. Hope you find it useful. So the learning objective on this slide, we hope students will be able to summarize and relate Newton's three laws to phenomena in everyday life.